A 12-volt electric motor has 900 watts input and 1 horsepower output. Maintaining the same efficiency, how much input power will a 24-volt, 1 horsepower electric motor require? And it gives us the conversion. So we have two different motors, right? So the first one is over here on this side, and it says 12-volt power supply, right? And it has 900 watts of input. So what it's saying is there's 900 watts to run this motor, right? So it takes 900 watts. And this motor is rated for 1 horsepower. And that horsepower will be stamped on the motor somewhere on its data plate. But that being said, so we have 1 horsepower at the shaft, the mechanical power. So we could convert that to electrical power. So we know 1 horsepower is equal to 746 watts. So the output of this motor is 746 watts, and the input is 900 watts. We see that the input is larger than the output, and that makes sense because motors will never be 100% efficient. If it was 100% efficient, the input would be 746 watts, and the output would be 746 watts. But that's impossible because there's going to be friction loss and losses in the electromagnetic field that it takes to run the motor and items like that. Okay, so what it's saying is we have this motor, and we're saying it has the same efficiency as the second motor because it says maintaining the same efficiency. How much input power will a 24-volt, 1 horsepower motor require? So we do need to remember what our efficiency equation is, right? So we know that the efficiency is equal to the output, and this output power over our input power. So every time we're talking about electrical power, we should be think the watt, right? Watts. Okay, so that being said, we can just solve for the efficiency of this motor here. The first motor, number 1. So the efficiency is going to be equal to the output, which is 746, divided by the input, which is 900. And that's going to come out to be 0.82888 dot dot dot. Repeat. This goes on with some repeating numbers here. 8's repeating. So we do know the efficiency is it's about 82.8% efficient, right? So that being said, we can use that and apply it to this motor here. So we know this one is 82.8% efficient. The more 8's I keep whenever I'm doing my calculation with these for this repeating 8's, the better, the more accurate I'll be. So we're going to use the same equation. Efficiency is equal to the output. We know that the output is 1 horsepower, or 746 watts. So we've got 746. Let me just start over here. Oops. All right, so the efficiency, I'm just going to erase this real quick. All right. The efficiency is 0.82888 equals the output over the input, or output power. The shaft is turning with 746 watts of power, and what we're looking for is our input power. So at the end of the day, when we're doing enough of these problems, we're always going to realize that we're just going to divide our output power by our input power. But if I multiply both sides by I divided by I is just 1. So I'd be left with 0.82888 I equals 746. Divide this side by 0.82888, and we know that our input is going to come out to be roughly 900 watts. All right, so maybe if we were a little quick, or we really had a good understanding of what efficiency is, we may have seen this from the beginning. We didn't even have to do any of this math portion. So let's look at that and look at why. So we know our output is 1 horsepower. What's our output on our second motor? 1 horsepower. Well, that being said, if they have the exact same efficiency, then what must they both have? They must both have the same, therefore, input power, right? Because if they have the same output, they have the same output, and they have the same efficiency. For this equation to be true, the input will always be the same, right? So if you happen to catch that. One other little side note here is these both have the same power input, right? So pi, P-I-E. Which one of these two, the 12 volt or the 24 volt motor, is going to have more current? Maybe you could figure that one out.